Problem number 5. An airplane flies east for 200 miles before turning 60 degrees south and flying for 100 miles. If a plane were to take a direct path to the first plane, what distance and direction would create the quickest path? Okay, so this is the lesson 4.8 that I kind of made up for you, direction bearing. So I want you to think of a northeast-southwest system. So draw a northeast-southwest system. When you draw a northeast-southwest system, what do I put right here? That's east. What do I put at the top? Okay, down here. And west. It says it goes 200 miles east. So draw an arrow directly to the east like this. And label that 200. You know what? I'm going to make it go a little bit longer so I can write with bigger numbers. Take my 200 a little bit further. Okay. Now it says before turning 60 degrees to the south. Now this is where you need to really pay attention. If it's turning 60 to the south, that's talking about from the direction it's previously heading. What direction was it heading? East. So this is like saying east 60 to the south. So what I'm going to do now is add a second arrow from this point. So from this point right here, tell me when I've gone about 60 degrees towards the south. Would it be like this? Is that 60 to the south? No. So think of a new northeast southwest from this point. So you start at the east and tell me when I need to go 100, which is about half of that 200. Tell me when you think I've gone 60 degrees towards the south. Right here? Okay, so if that's 60 degrees, come back and now let's add to our chart a 60 right here. And the length is 100. Now, it says if another plane were to take a direct path to the first plane, what distance direction would create the quickest path? Like if they went exactly straight to that point, what should that airplane do? That's the question for us. Again, what shape does it look like we have here? A triangle. So we can solve it with triangles. Right now, I have two distances, but no angles. But we could find an angle. Here, this the east-west line has a total of how many degrees? 180. If 60 of them are sitting right here, we could figure out how many are sitting on this side. How'd you get 120 so fast? 180 minus 60. Good. That is 120. If I wanted to find this distance here, I'll put it as an x. I have to find the distance and the angle, so I'll do an x and a theta. For the distance x, would I use law of sines or law of cosines? Law of cosines, because do I have a completed set? No, so I have to complete a set. Cosines will complete this set right there, but right now I don't have one. So using the formula chart from over here, the law of cosines is shown right here. Use this when you do not have a completed set and you want to create one. So there's my law of cosines. Because it's going to get covered up, I'm just going to copy and paste it here. And shrink it down. Okay, so there's only one place that 120 degrees can go. What's the only place for 120? Capital A. Since 120 degrees has to go there, that means I'm going to solve for lowercase a. That's what I'm going to find here. That's my x according to my drawing. B and C, it does not matter which one you put in which location. You'll get the same answer either way. So what do y'all want to put for B? So 200s for B, which leaves us 100s for C. Now, if you don't want to insolve this, let's just think through the formula. Right now, it would be x squared. What's the opposite of squaring something to isolate that x? Square root. And we know it has to be positive because this is a real life, real world problem. And so the answer must be positive. Can't go a negative distance. So a would equal the square root of all that. No, I'm sorry. X, as we were replacing it with an x. So let's type those in and see what we get. Square root 200 squared plus 100 squared minus 2 times 200 times 100. Whoops. Cosine of 120 degrees. And again, make sure you're in degree mode, or you could press the pi button and choose the degree symbol just to always make sure you get the right answer. That'll always work no matter what mode you're in. I'm getting 264.575. 264.575. This would be in miles. That's the distance traveled of that airplane. And now that I know the distance, now that I've discovered this is 264.575, how could I find the angle that the airplane should travel on? I now can use law of sines because I have a set. So now we'll use the law of sines and say that sine of 120 degrees divided by our x, which is 264.575, should equal sine of theta divided by what angle is across from theta? I mean, what side length is across from theta? 100. You can then solve this or cross multiply, divide. I'll let you in solve. All right, after typing in all this, what value are you getting? 19.1 roughly. Okay, if it's 19.1, the way they would probably write the answer, if they're using a northeast-southwest system, is this angle, this 19.1, is going starting from what direction? Starting from which one? East towards the south. So they'd probably write the answer as east 19.1 degrees south. That would be your final answers there. All right, I have a DOL for you. DOL number 5. On this one, they don't give you a drawing, but it just says a boat is anchored at a point B in a river. So if I were you, I would just draw something represent a river. And point B is just, it's anchored somewhere in the river. So just draw your B somewhere in the river. And it says there are 2 boat ramps on the far side of the river. So you can pick, I'll just put mine on the right side. Points A and C. Ramp A is 200, part C is 175. So I'm gonna try to make A a little bit further away from B. Kind of like that. And it gives you the angle. It says, what's the approximate distance between the 2 boat ramps? So that'd be the distance between B and C. So I'll let you label and solve from there. But I'll give you that to help you out. Oh, whoops. Boat ramps A and C. Good call. There you go. I'll let you solve that.